Alright, so we have a sorted data set here, but data sets don't come sorted. In fact, a big job of programmers is sometimes to sort data sets. So this is the result that we would like, but let's start with something that's a little bit messier. So we'll mix this around a little bit and put it out again. And we now have a data set that is not in sorted order, and we want to fix that. Now, the easiest and kind of most straightforward method of sorting is a process called selection sort. And what that means is that we go index by index, and we find the thing that is supposed to be there, and then we move on. So we're selecting the card that really is supposed to be in the spot. This involves two indexes, or two things to keep track of. One is going to be where I'm currently focused on, the spot I'm currently trying to fill, and the other is going to be focused on what card I'm currently looking at. And we actually have a third that will be indicated by this handy dandy pencil, and that's going to indicate the current lowest card, or the current card that I really want to put into the spot. So let's start with the beginning. And I have all three of my values are pointing at the same spot. I'm trying to fill this spot. I'm currently looking at that card, and so far that's the smallest thing I found. Now I'm going to move on, and I see that a 2 is smaller than a 7, so I now indicate that by moving my pointer to the index of the smallest value, and I continue to look on. And as I look on, I never find anything smaller than the 2. So after I've done one whole pass of all the cards that are down the table, I can conclude that this card really needs to go into that spot. So in order to do that, we're going to perform a swap. Now, a swap happens when I move a value out of a place, or I make a copy of it, move this first one into the place that was freed, and then take this card from that temporary location and put it in that index. So now we reset, but my left pointer, the one keeping track of the spot we're currently trying to fill, moves over. So I start again, and again we'll say that 7 is the smallest card, and I'm looking at 7. I have my lowest card index point at 7. I move over. I see that 3 is smaller than 7, so my smallest card index gets moved over. I look through the rest of the list, and we can conclude when I get to the end that the 3 needs to go there, and we do a swap again, very similar. That goes up, this comes over, and this comes down. So now I move my index for what position we're trying to fill, and we do the process again. Now this time, I start with a 7. That's smaller than a 10, so I don't move the index of my lowest card. 9 is still greater than a 7. I don't move that index. 5 is smaller, so my index moves, or the pointer that's keeping track of where my lowest card is. I keep going. I found out that 4 is the thing that's smallest, so I move it again. I get to the end of the list. I can now conclude that 4 is the thing that is smallest with what's left over. So I perform a swap again. And this process continues until I've gotten everything in sorted order. So the rest of these swaps would look like this. We do that swap, and then the 6 is the smallest thing that's left. So we do that swap. And then 7 goes in, and then 8, and then 9 and 10, and then we are back into sorted order. So that is selection sort. Selection sort's relatively easy to code, it's relatively easy to work through, but it is not a very efficient sorting mechanism. So let's look at a couple other ones that might work a little bit better, and especially work better in special circumstances.